Good afternoon, and thank you for joining us today for the second event in our Practical AI event series. My name is John Lazar, and I'm the president of the Royal Academy of Engineering. And it's my great pleasure to be hosting this series of online fireside chats where I speak to AI innovators and adopters to get under the skin of what it takes to responsibly integrate AI into everyday infrastructure and services to improve people's lives all around the country. Earlier this year, the government launched the AI Opportunities Action Plan, a strategic roadmap designed to accelerate AI adoption, enhance infrastructure, and support development of talent. But we know that AI adoption can be challenging and painstaking. It requires an understanding of the problem you're trying to solve, the right data and technologies, and a collaborative effort to manage downside risk in a way that builds trust. Our Practical AI series aims to share stories about where this has worked well to support our audience to navigate some of the common challenges. With growing discourse about the risk that the so-called AI bubble could burst due to organizations experiencing limited return on investments in generative AI, we also wanted to focus on examples where AI has delivered measurably better outcomes, or to what extent it has been put into practice, or where it is being tested in ways that can lead to better outcomes. That's why I'm truly delighted we're going to hear about what embodied AI can do to help maintain the Thames Tideway Tunnel, a large sewer system supporting Londoners. Even a small London rainstorm can overwhelm our Victorian sewers, causing about 39 million tons of raw sewage to spill into the Thames every year. Tideway is a so-called super sewer designed to change that. It's 25 kilometers long, and it has around 1.5 billion liters of storage capacity that, once fully operational, is expected to cut sewage overflow by about 95%. But building the tunnel is only half of the story. Protecting that performance for decades depends on how we inspect and maintain a vast, hazardous, hard-to-access asset, which is exactly where AI-enabled robotics can help. The work we'll discuss today is in the early phases. The team has demonstrated the system in a controlled area within the tunnel, but it hasn't yet been deployed as a routine, business-as-usual operational inspection. They'll be candid about what has been proven so far, what's still to come, and what it takes to get from trial to trusted operations. Our conversation is taking place the day after the Royal Academy of Engineering published our new report called Reviving Our Aging Infrastructure, calling for a more proactive approach to stewardship by moving from a fix it when it breaks mentality to monitoring and maintaining, supported by better data skills and long-term decision making. And that's exactly the lens today's discussion sits within: how you build practical capability to understand asset condition, plan interventions earlier, and keep people safe while doing it. Before I get the ball rolling, we would love to hear from you first. So please join our Slido by following the link in the comments to tell us how confident you are using AI. And while you're voting, I'm going to introduce our panelists. I'm delighted to be joined by the innovators who've delivered this fantastic example of practical AI. Firstly, we have Juliette Levit, a robotics engineer at Amentum, specializing in remote operations and mechanical engineering, who's been involved in the tunnel inspection project since early prototyping. We're also joined by James Kell, robotics technical director at Amentum, leading robotics and remote handling systems for critical infrastructure, with experience transferring robotics from sectors like nuclear into areas including utilities. And for the adoption perspective, we're honored to have Roger Bailey, Chief Technical Officer at Tideway, who's helped define how Tideway's assets interact technically with the existing Thames Water network. And also from Tideway's side, we're joined by James Spikesley, Service Program Manager. Now let's take a look at your votes. I'm just going to pause for a minute and see if we've got the votes coming back. Well, we've got a pretty confident audience. So 50% confident about AI, 25%, not so much, and then down to a very confident 13%. So this is an interesting audience, and one which I think will enjoy the conversation we're about to have. Well, I've got lots of questions for our panelists, and I will have more as we go through the conversation. We want this to be a wider conversation. So just drop your questions into the comments, and we'll try to get through as many as possible. Right. Let me start with setting the scene, and I'm going to go straight to Roger. Roger, could you start by setting the context for us? When you started, what problem were you trying to solve when it came to inspecting the tunnel's condition? And how did it lead to you thinking about an AI-enabled solution? So I guess part of the question is like, how does this solution differ from approaches where you wouldn't be using embodied AI in terms of the times taken, the frequency of inspection, and so on?
Thank you, John, and welcome everybody. Yes, I'm Roger Bailey. Yes, if we could start, if you could show the drone deployment photo, Simon, that's great. So yes, this is a cut through of our project at near the Victoria embankment in London. You can see opposite the London Eye. This system you mentioned about it cleaning up the river. It is cleaning up the river now. Since February 2025 this year, we have been pretty much fully operational, and we have captured over 12 million cubic meters or 12 million tons of sewage since then. And there are many people who use the river anecdotally saying it's the cleanest they've ever known it. It now smells like the sea and not like a sewer. So that's great. On the project of inspecting it, because that's what this is about, inspecting it. It's designed for 120-year design life, which, as many of you know, means it doesn't crumble to pieces in 120 years. It's actually starting to deteriorate. So we need to make sure that over that 120 years that it's still properly functioning and there are no issues there to be looked at. Now, when we started many years ago, 12 years ago, the plan was to do that with individuals, to go down into the tunnel, which is average of 50 meters deep. It's a single sort of system. So unlike a railway or some other facility where you can shut bits of it, look at everything, we shut any of this, it's basically out of action. So it's very important that it stays operational, and that anything that takes it out of action will then lead to almost the whole system potentially going and discharging again if there's a storm into the River Thames. So that's not what we want to see. So the original plan was for a human survey, which would have involved access at many points, making sure things are safe. I won't go into all the details, but you can imagine there's a lot of backup and facility requirement to make sure that is safe. You can get people out, so there's doubling up of cranes, doubling up of ventilation, rescue people, etc. And that does mean that the river would be effectively unprotected for a considerable number of weeks. So our desire with a robotic or remote system is to be able to go down and to access and look at and see the tunnel in its glory at depth, by minimizing the impact on the environment, by minimizing the outage that we take, and also at the same time to probably increase the quality of the information that we get from having a mechanized automated system.
That's fantastic. I mean, that's a good segue, actually. I'm going to move us on, actually, to take that sort of basic requirement at the top level and then think about solutions and go to James Kell from Amentum. Can you sort of set the scene, James, from the delivery and robotics side? How did you translate that operational need into a workable solution, and what were the early design choices that mattered most? And I'm really interested in your previous experience in other sectors. Was there anything that you brought across there that you thought was particularly helpful, e.g. from nuclear?
Yes, okay. So, we're problem solvers within Amentum. So we're a global engineering and technology consultancy business. We support government customers across defense, space, infrastructure, and more. Juliette and I work in a robotics and remote handling team. We operate across sectors there, which mainly bring proven technologies and approaches from one domain into another when it helps us solve challenges. And generally speaking, we're an integrator. So we'll look for those types of solutions and things that we can take off the shelf and build and use in different places. And because we've deployed all sorts of different remote handling robotic systems into those types of sectors, we know the types of people we can work on and rely on to put together a decent solution to provide the asset owner with the kind of information they need. Because really, they're not interested in the robot, they're interested in the data itself, so they can perform those types of decisions and make your next move, really. And then whenever we don't have those type of technologies, we can rely on our university partner network. So we've been partnering for a number of years now with the University of Manchester and their robotics team, with a thing called the Cradle Project and Cradle Initiative. That's the Centre for Robotic Autonomy in Demanding and Long-Lasting Environments. And that basically is a team that helps us to meet the needs of our clients faster, safer, and better. But coming back to your original question, how do you tell them those kind of requirements into the actual specification? Fundamentally, and coming back to the point I made earlier, we're problem solvers, so we always take the type of approach where we're looking at systems engineering to break down the requirement properly, understand what the real question is that we are being asked. Because as I said, they don't want a robot, they want the actual data. So it's looking at all sorts of options, what's off the shelf originally, what are the real challenges that exist, and it's early and often dialogue with the customer and the client that helps us get to those types of points.
Yeah, that's really interesting. And yeah, I mean, we'll come back and talk about the data later, I think, because that's a super interesting point. Sorry, you were going to say something else.
No, the only thing I was going to mention is just sort of shining a light on what was said previously. It was very early on when Tideway decided to put robots into the sewer instead of people, and I think that is worth celebrating, because I don't see that very much in the infrastructure world. It's often an afterthought. And I'd like that to become business as usual, really, which is in terms of help with adoption of robotics and AI.
I was thinking about that, and I was thinking about going back to Roger and asking him, like, can you pinpoint the date where you thought, we're going to use robots? Because if you did that 10, 11, 12 years ago, I think that was a pretty prescient decision that you might have been taking.
Well, that was where we did it pretty much after we got our license, and even before then, because putting people down into a tunnel and moving along it several kilometers is full of risks, and other deep sewer systems have done this once or twice and then stopped doing it because of that, because they haven't seen that much change to their asset, but and also because it is quite a risk laden thing to do. So right from the word go, we decided we would aim to do this remotely, and we had an initial project that concluded in 2017, 2018 with a company that came from the sort of space sort of sector, had been doing sort of Mars type rover lander vehicles, and they were developing for us a fully autonomous vehicle that could set off completely independently from one end and get to the other end, or turn round and come back if it found the way barred by some obstruction or something. That did prove in 1718 to be too expensive for us to contemplate. It was something like 2 or 3 times what we thought a manual survey was. So we left it for a few years, waiting for technology to catch up, and then started again in 2022 with Amentum. Well, with Amentum and others pitched to us, and Amentum won the first round of that, and then we're on the journey with them now.
Fantastic. I want to go to Juliette and to talk about how the solution works in practice. So what's been demonstrated so far, where it adds value. Can you explain the inspection system in broad strokes, and then where the AI specifically is doing the work that Tideway needs from it? In other words, what have you been able to demonstrate so far in the tunnel, and then what does the AI unlock in terms of output?
Yeah. Yeah. Hi everyone. Yeah. Simon, if you could put the a schematic, so to have a bit of a visual. Yeah. So as you were saying, John, so we have this system, and as James and Roger previously mentioned, we want to inspect these tunnels fully remotely. Don't put anyone at risk whilst doing it. So in this picture you can see on your screen, there's different systems. So I'm not going to talk about the one in purple because that's uh, basically adjacent connection tunnels to the main one that we haven't demonstrated. The one we focused on with our technologies are the green square, which is inspection of the shaft to access the main larger tunnel, where we put down drones and different technologies like LiDARs, for example. And the one I'd like to really highlight here, where we used a lot of AI, is the one circled in blue, where basically you can see a shaft to access the tunnel. And what we decided to test is lift up and down the robot with a lifting cage, lifting basket that is remotely open when it reaches the bottom of the shaft to release the robot. Then the robot undergoes the inspection in the system and either goes back to the same lifting basket or goes to the end of the tunnel to another lifting basket to retrieve it. So the main challenge here, as you can see, is when you're that deep down below surface level and that far down, kilometers down a tunnel, it's really complicated to keep communication and have the data that you're inspecting communicated back up. So when you think about, for example, your Wi-Fi router at home, and when you just go to a next room and there's already out of range, no more, no communication. Well, we decided to use radio because it has a longer range. And this lifting cage was used not only as a lifting device, but also as an antenna to communicate with the surface and with the robot as well, to have a full link of communication. If you can go to the next picture, please. Yeah, so as I was saying, at the top we had a van, a control van. We were able to teleoperate, which means drive the robot in the tunnel, seeing visuals. And whilst driving, it was automatically recording any data. So the type of data we're trying to gather here is to identify any blockages, any defects, any other type of feature like that would require further investigation, for example, in the future. Um, yeah. Uh, a big part of AI that we use here is when you're down the tunnel and you gather different type of information. There's a lot of data, and without the use of AI, when you take thousands of pictures, you need to have someone that has to go through each picture, and this has the potential of human error and will take a long time to go through each thousands of pictures. So what we decided to do is use AI to identify different pictures. So for example, on the bottom left picture, there's a yellow marker. And inside the tunnel, we have these markers at a known distance from each other. So what we identify is, if we use AI to reliably and quickly identify these markers within the big pool of data, big pool of pictures we have, then we can identify the timestamp of each picture, and this will help us better localize the robot inside the tunnel when it drives. So that really helped us, do the inspection, post-processing in less time and be more reliable. We also used AI for crack detection. So as you can see in the bottom right picture, this is a 3D map point cloud of what we the pictures we took in the tunnel. Sorry. And once again, crack detection would have taken so much longer and prone to errors without the use of AI. If you had someone that had to look through thousands of pictures to identify different type of cracks, and they have different shapes and sizes, so it will be really complicated. But we actually used like a pre-trained model that went through the thousands of pictures taken during the inspection to identify them. And then that saved post-processing time. And yeah, the last point I think following that is the object detection. I think is in the next video and picture. Yeah, nice. So in the picture, in the video, sorry, on the right, you can see the robot driving in the tunnel, and on the left is actually a screencast of what the operators were able to see. And in the screencast, you can see there's different boxes appearing in front of the system. And these boxes were object detection, which is basically a primitive version of AI, simply because we didn't have previous data of what we could see in the tunnel. So we used more rules, primitive rules, such as the size of an object. An object has to be static, it has to touch the ground, for example. And that really helped us later on identify what was in the tunnel, if there were blockages or not.
Fantastic. Thank you. That's really helpful. Brings me on to our next question. Actually, I'll direct this, I guess, initially at the Tideway people, but I think James Kell may also want to come in. I'm interested in failure cases here. So when the robot's performance isn't reliable enough in practice, like what actually happens? Do you pause deployment? How do you add human checks? What do you revert to as another method? And also, how do you manage a false positive or a false negative in this kind of safety critical context?
Do you want me to pick up on that, John?
Yeah, why don't you go first, Roger? Then we can bring James and James in.
Yeah, so I mean, obviously we are in the process of finalizing over the next year or so the final design that will be hopefully implemented in early 27 for this remote inspection. And we've done the trials and they were pretty good, but the reality that the tunnel wasn't in service. And one of the things is, how is the tunnel going to be for the robot to transit through it when it's in service? Is there going to be some silt build-up or any obstructions or things which are going to make that really difficult, for example? So we need to do a live trial, and we need to make sure that when we get to that point, we're pretty certain it's going to work, and that's a challenge of the next year or so, I guess. If we get there and we find that it doesn't work for whatever reason, then we'll have to revert back to our human-based survey systems. However, one of the things that is happening, obviously, technology is moving on, each week or each month or each year by bounds. So drones, for example, opposed to robots. So the sort of the proposal is that we would do shafts with drones. We've already been doing that, and the near ground structures as well, which are where the interception points are at the top of that shaft I showed you in the cutaway. That has all been done with drones already successfully as part of the completion of the construction process. And it may be that there's more drones can do more and go further up the tunnel than they have. They definitely will be able to do more in a year's time than they can do now. So we may have a system where we could operate some sort of a hybrid drone and robot solution to give us what we need. So that's sort of where we are. We are on a journey, John.
Yeah, no, interesting. Thank you. Can I go to James and James? Anything you want to add to that question?
I just throw in a little bit there. So our system is designed, I suppose, to pull in all sorts of information from multiple sources. So there is a big challenge around data handling, and that can be improved certainly through AI, and Juliette touched on it. But it's a case of putting together that 3D digital jigsaw puzzle, if you like, to make sure that you can take those sources from all sorts of different places and make best use of them. And it's really about practice. So we just talked about how to describe and improve that concept of operation, if you will. And with the gaining of more information, more data, we'll be able to prove to the client and all the other asset stakeholders that what we're doing is proven and trustworthy. I think that's the most important thing.
Yeah.
The other thing you did touch on as well, actually, that mitigations if something went wrong. So we have also proven ways and demonstrated ways to retrieve any hardware that failed within the tunnel as well. So that's also front and center in our minds too.
James Spikesley, anything you want to add to that?
Probably the only thing really is obviously both Roger and James have covered the majority of it. It's just a bit back to the environment itself, having not sort of been down there. And should there be a fault within the robot and it gets stuck halfway down it, for instance, the complexity of being able to recover the robot through the whatever condition that we're not quite sure, could be silt banks, could be ponded fluids, so on, and then you've got to actually lift the robot out of it as well, and then it's I think they're sort of circa 400 to 500 kilos. So then you can start thinking about how you undertake that overall recovery position to make sure that we sort of get the data that's been taken to that point, and then as Roger sort of described, we then have to make a decision about how we then move forward following that.
Fantastic. So I want to move us on just to do these next couple of questions really, really quickly. So a big purpose of us doing this practical AI is to be candid about what didn't go smoothly. So maybe I want to have each of you just pick one thing as you've moved from, you're moving from concept to trial and hopefully to deployment. Like, what's the biggest lesson you've learned? Very quickly. I'll start with you, Roger.
I think it was that the radio could work, all the way down a 7-kilometer length of our tunnel. So 25 kilometers long in total, the main tunnel, and it's split into several 5 to 7 kilometer sections. So that was great to prove that with the trials a year or so ago. And I think the other thing is sort of we've done our 3D point cloud surveys of all of the asset, which has been done by our contractors, and the LiDAR survey element that does a 3D pass-through survey of the whole tunnel, and that can then be compared with the original one to check that there's no changes from the original geometry before the tunnel went into service. And that, I think we're confident that we can do that. I think the key issue is about getting the device through the tunnel reliably and out the other side. I think the kit that's on it is quite well understood now.
Yeah. Let me come to the Amentum team. What was the biggest lesson you learned, biggest friction or failure that helped you along the journey?
Glad to hear Roger mention the radios. It's something that we were concerned about though at early days. And it's one of the things we demonstrated and we could prove, or we had proven technology for the military types of deployments were done in the past. So that's something we relied on from different sectors. So that's another good news story from a tech transfer perspective. I guess I'd reflect on things that would be improved upon or it didn't go so well, perhaps. The choice of our early inertial measurement wasn't quite up to scratch, but we took a different approach and demonstrated that above ground to the tideway later on, which improved our precision and navigation and timing type of aspects much better later on, I think.
Juliette, do you want to add anything to that from the sort of technical point of view?
Yeah. Completely agree with what was said before, and I think maybe more linked to AI directly. The fact that this was never done before, so we didn't have previous data of what will be inside or things like that. When you use AI, you have to train it. It has to come from a known database. So I think building from that, now that we know what it looks like inside, different features, and for example, the quality of image we need, I think we really built a lot of knowledge and experience, and now it works a bit better because we were able to learn from that. but at the start it was a bit challenging, because when you put a technology in an unknown environment, you actually don't know the type of data you're going to get, or if your system needs a specific type of data, you can't train it yet. So yeah.
Yeah, very interesting. If another, I've got a follow-on question. I mentioned this. If somebody approaches Tideway and it's another water infrastructure operator, and ask you like they want to replicate this, what is the biggest question you would pose to them? What would you warn them about?
Well, I'm not sure. I mean, we haven't yet got to an end point, so we're still going through our story, John. But the process is, I suppose, maybe we started off, and I'm talking about the earlier trials that we had back in 2017, 2018, trying to be too sophisticated in what we were looking for with a completely autonomous unit. And we were pretty certain you couldn't communicate down the tunnel. So, and nobody came up at that time with that as an option. Clearly, 4 or 5 years later, Amentum and have showed that's now not the case. So I think it's probably try and keep what you want as simple as possible, but also be very agile in your development and how you're working with your partners, so you can flex to accommodate what you're learning from what you're finding out. Because we know a lot more after the trial that Amentum did. Was it last year or the year before? It's it must be the year before, because we were we need to learn from that, but also set up a sort of minimum viable product rather than something that's perhaps super sophisticated, and then crashes because the program crashes because you've tried to be too clever.
Yeah, no, that I think that's a really interesting lesson.
Could I add a couple of tiny points? One thing would be to be really clear on requirements and be kind of specific about those as best you can, but also, I guess, also realistic. And Roger was talking about being simple. I think that's perfect. I think the other thing that Roger touched on as well is actually trying things out for real quickly and see what would work and what wouldn't. I think as best representative conditions as you can find. We tried all sorts of places that were as similar as we could get to the big tunnels, but clearly there's no substitute for little them.
Yeah, that's really helpful. So Roger's laid out, I think, a little bit of the journey you're going through, and fingers crossed it gets to full deployment. But I want to come back to the data point. So, where, from an operator's perspective, as you move into sort of full deployment, what are you planning to do with the inspection data? Like, who needs it? How does it enter into your decision making? What changes once you get that better evidence faster? So, like, how are you thinking about this absolute shed load of data that's now being generated?
That directed to me or to James? It's like,
well, I was starting with you, but I'm happy to have James Spikesley pick it up, Roger. That's fine.
James, do you want to answer that one?
Yeah, certainly. So, so one of the requirements for the surveys is that there's sort of 4 categories associated with the sort of defects or items that are recognised through the survey. And what will happen is there's different speeds of reporting, so that if we need further data, we can get it sort of fairly promptly. But also it'll allow us to sort of plan for future works. So once we've got the body of data, then it may sort of indicate that there has been a crack somewhere along the tunnel that is a bit bigger than we would like. We wouldn't necessarily need to do something about it at that stage, but we will have a report that when we next go back into that section of tunnel, we can directly relate it back to that specific crack, so we can determine whether it's healed itself, whether it's got bigger, or whether it's an indicator of some some wider issue associated with that area of the tunnel, and it could be that there's been a bigger development nearby, and that's had sort of an unintended impact upon it as well. And it's a point that Roger touched on earlier, which is being able to compare the overall sort of tunnel and sort of shaft data with the baseline that we currently have that have been done by our main works contractors, to understand if there has been any changes within the structure of the tunnel, whether it's overlies at all or sort of had any sort of changes to shape. So that should give a solid solid batch of data in which we can sort of determine the true health of the asset as we move forward.
Right. I'm going to ask one sort of final question. We've got some really fun questions coming in on the Q&A, which I want to pepper us with in a minute. But Roger, I just had a final question for you, which is a sort of broader question around regulation and policy. From your perspective, from Tideway's perspective, is there anything that you would want regulators or policymakers or government or industry bodies to really understand now about making adoption of this kind of solution easier? Is there anything we need to be changing in people's mentalities and thought processes and outcomes?
Well, I think I would turn it the other way around. There's nothing that they're saying that would stop us doing this. But I think, as James Kell mentioned, so Tideway has taken a view. We want to do this remotely for lots of reasons: health and safety for people, probably the primary consideration. Protecting the environment, so it's a shorter outage, and also then better data, because you're relying not on people down there, but a piece of equipment that's going to capture everything. I think what we need the regulators and to do is to actually challenge utilities to do more remote sensing now that it can be done. And so why aren't you using remote devices to do this sort of work, and thereby doing those improved things for data, for people, and for the environment? So I think they need to be more proactive than and sort of encourage organizations to do that, and hold them to account if they don't.
Yeah, I think that's a great answer, actually. We need to be more challenging for the industry. So I'm going to move us. I've got so many follow-on questions I could ask, but let's move to some audience questions. And there's two practical questions, which I think are great ones. So, as you move from trial into full deployment, there's two questions about the robots, which I think are interesting. One is how's it supposed to work when the robot is fully submerged underwater or sewage? So how are you thinking about the design of the robot? Is it resilient to that? And the second is, do you have issues with the stability of the robot when it's going over rough surfaces or cracks? I know you talked about retrieving them, but what happens when it falls over? So I think maybe let's answer those in one go, just thinking through robot design.
James, Kell, do you want to answer that one?
Well, okay, so firstly, we've been designing with the final solution in mind. So the whole of the translation of the locomotion unit can be hermetically sealed. But I know it looks like a tall and unstable object moving along, but actually we've simulated and done trials where we've gone over various obstacles that show that we've got a good degree of stability and stopping anything from falling. So we're not so worried about that just now. But as I said earlier, if something does happen where we have an experience of failure when we're in service, we have got ways to retrieve the hardware.
If I could just add the comment about submerged. So the tunnel will be empty. It will be pumped out dry. It will be all of the penstocks, the valves that will be closed. And for the first time we do, we'll also put secondary isolation gates down as well. So there won't be any liquid in the tunnel. What there may be is silt in various forms of hardness, softness, wetness in some portions of the tunnel. But we don't expect that to be the case. The tunnel has been designed to be self-cleansing, but it's self-cleansing over time. So between a storm, you might get a build-up that's then going to move away by the next time that a storm comes into the tunnel. So temporarily, there might be a slightly larger build-up in certain areas. So the robot has to be able to get through something, and until we have a little bit more understanding of how the system works in reality, it's difficult to know quite. That's the key risk, I think, going forward.
Yeah, no, that's really helpful. There's an interesting follow-on question as well, which I like, and that is, are you ultimately going to only use the robots for surveying, or do you think you'll get to the point when you can actually have them do some of the repair and maintenance? What's your thinking about that long term?
Well, we don't plan to do any repair and maintenance because the tunnel is designed for a 120-year design life. Repair and maintenance is required for the mechanical electrical equipment, which is in the near ground structures, which has got access easily or relatively easily from the surface. There's no mechanical electrical equipment in the tunnel below about 15 meters. So it's all just reinforced concrete, shaft and tunnel. There are the big pumps that Thames Water have down at the Tideway pumping station in Beckton. That's been going for several years now as part of the Lee Tunnel, and that continues as a sort of tried and tested sort of operation. So there's what we're looking for, and the key risks are really, in time, hydrogen sulfide, because of the gases in the tunnel causing corrosion, particularly in the tops of the shafts, and seeing that and how the tunnel is designed for that. There's sacrificial thicknesses, but are we burning through that quicker or less than what we should? And the other thing is actually more in the shallower parts of the tunnel, in the east, in the Greenwich Connection Tunnel, which goes from Greenwich through to Bermondsey, and in the west, where the tunnel is underneath residential or development areas, where the main risk is somebody not doing their surveying properly and not going through the right process and putting a piling rig through one of our tunnel sections. That's something we have to safeguard, make sure there's no risk of that, but it's not an impossible thing to happen. So other than that, we expect the tunnel to last its lifetime of 120 plus years.
That's where a minor point to add on to Roger's points there, but completely agree. We're not talking about maintenance from a robotics perspective within the Tideway project. However, we in Amentum have done this type of inspection and maintenance type procedures across all sorts of infrastructure. So you'd be surprised at what we could do. It's another conversation, not for today, but if you're interested, do please have a reach out.
There's an interesting follow-on technical question, James, which kind of picks up on that, and that's what advancements in the next 5 to 10 years do you believe will make intelligent sewer robots completely autonomous? Is that possible? And there's a question for Juliette as well, I think. Is that possible?
Yeah. Well, yeah, definitely possible. But as you're saying, it just takes time and development and obviously funding, because I think the initial cost of development is always a bit scary. But there's definitely a lot of advancement in the software, and it's linked to what I was mentioning earlier of the more data, the more understanding of the system we have, the easier it will be to actually design something fully autonomous. If we kind of already know what we can expect down there, we can do that. We've already have experience now with radios, with communication, images. So it's just pushing further this technology that already exists. And some of it is maybe not on the market already. For example, more if different sewers are fully immersed, for example, it will be using a sonar or different things. But yeah.
Yeah, there's a follow-on question there, which I'm also interested in. I was going to ask this question. So you've also talked a little bit about the AI specifically that you use. Can you flesh that out just a bit to talk about exactly what the AI is that's currently running on the robots, and how do you think that may change?
Yep. So at the moment, it's mainly for processing the data, and it saves us a lot of time, and is a bit more reliable. So at the moment, it's mostly for post-processing, but we can imagine in the future to have this for real-time detection, autonomous driving as well. Yeah, I think it's mostly with the data, having all this kind of more automated.
Does that change the computational requirements on the robot itself? Are you thinking about longer term changes where you have to put more compute on there?
Yeah, so it is a good point because using AI also implies a lot of data. So you have to store your data, which, for example, is data center, but you have also to have powerful processors, for example, and just the sheer amount of data. Using radio is great, but it also means you have such a specific amount of data you can share before. Before, for example, your camera to drive stops lagging or things like that. So you have really to find a trade-off between you need to collect a picture, but if you want to post-process it automatically, like real time with AI, then it will require further storage and data transferred. So it's a bit of a trade-off using it and using it wisely, not just using it for the sake of using it, because there's already really powerful softwares or code that doesn't require it. But if we can improve it and make it better using AI, then definitely, yeah.
Very good. Well, I'm going to move us on to a final question. This is very much picking up on what Roger and others just said about where you're at in the project. And as we move from promising trial to hopefully full deployment and then just business as usual for maintaining the infrastructure, like what is the one key thing that has to happen from each of your perspectives? So I know lots of things have to get proved out and we have to make sure it works in the full environment, fully operationally, but in your mind, like what gets us to full business as usual deployment? And then I'll start with Juliette and then work around to each of you.
Sorry, can you repeat that?
Yeah, I'm asking for, as you move into a full deployment, full operation, maintenance as usual, what is, in your mind, the biggest hurdle, the one big thing that you think will need to get solved?
um, I think, at least from also previous experiences, not just for sewers, uh, how the infrastructure is first built. Sometimes, so Tideway did this amazing thing of they were thinking of doing it remotely really early on in their design, but there's some infrastructure that maybe didn't think about that because it was so early on years ago. So maybe if now we start making infrastructures that already have how can I say, for example, access easy for robots, and think, oh, in the future there's going to be remote systems that are going to go down, and start developing them from the start. I think that would be really good. Yeah.
James, Kell, anything you want to add to that?
Yeah, a tiny bit. And I had the same mindset as Juliette, actually, just thinking a bit wider in terms of the culture of the doctrine of robotics. It's not such a problem necessarily within the Tideway compounds because they're designed a bit more for maintenance and inspection, but it's something I'd really be keen to promote across the infrastructure world and see this Tideway and maintenance inspection as a good partnership and a way of describing how things could go well in terms of design and maintenance.
Let me come to the Tideway people. Roger, you said there, hopefully we have a successful rollout in a couple of years' time. What are the biggest hurdles we have to get over to get there?
Well, I think there's sort of two things really. One is just the reliability and resilience of the robot to get from one shaft to the other through whatever it finds. And we're not going to be absolutely positive on that probably till we've done it several times over several years. But because, and it is, as I said, at any one time you may get some silt in there or not, and how much can actually go through, and does it cause a problem? So that is a very practical thing. I think the other thing was when the very original proposal was that every 10 years there'd be an inspection. Well, as an asset owner, I quite like to see my asset more than once every 10 years. And also, if you do it every 10 years, anything that you've done to get access down and to do it is going to have rotted in the warehouse and the people have gone on to other things. So what we want to do is to do this first survey, in 2027, really, and then instead of waiting 10 years to do the next one, to have it as something that we could go down at any point very easily, almost at the drop of a hat, either with a robot or with a drone. And so if somebody did suddenly hit the top of our tunnel and stop in Chiswick and say, "Oh, I'm terribly sorry, I got my survey point wrong," we could actually quickly come along, go in and at least see inside whether or not there's any evidence of that, and have a look at it within literally hours potentially. So you wouldn't want to wait 10 years to be coming to do that, and you wouldn't want to shut the whole tunnel down for something that maybe was an unlikely issue. So I want to get this remote surveyed as being like another tool in the asset management arbor of the future that can literally very quickly get down and get really good data that can compare with the historical stuff.
Yeah, fantastic. I mean, that's a lovely way to conclude. James Spikesley, anything to add to that?
But just one more thing, actually, John. I think sort of people have covered sort of most of the things. I guess sort of one of my thoughts is just around the piece surrounding the water industry, and actually the industry, if they came together and actually provided that sort of level of support to allow the development for the tools that should be made available to the wider industry and the water industry in general to address the safety concerns associated with people going down and trying to remove that sort of human element wherever we can, would improve obviously not just the safety of working, but also the actual overall intelligence that we have with all of our sort of water infrastructure in general.
Very good. Well, I think we're coming to the end. So sorry to say we're running out of time. Going to wrap up in a few minutes, but at this stage, we'd love to hear from you again. And there's going to be a link in the chat, may already have happened, to answer a quick question via Slido at this time. And we want to know if your thinking on AI adoption has been influenced by today's event. So please vote. And while you're voting, I'm going to say a huge thanks to James and Roger and Juliette and James for a really interesting and stimulating discussion. And I want to thank everyone else also for joining us online for your insightful questions. It's been a really interesting and practical conversation, and I've certainly learned a lot. So let's see what's come through. I'm going to pause for a minute and see if we've got some answers. And yeah, I think so. Nobody said it has influenced them, not at all. So that's good. And then we've had, a lot of thinking being influenced at 50%. So it's nice to see those comments coming through, and that's also good feedback for us as we move forward. So if this conversation has sparked your interest, or if you have any further comments about today's event, please come back to us, propose some topics for us to consider, respond to the survey that's been posted in the chat, and it will also be emailed to you following the event. And we really do like the feedback. It helps us to shape and improve future events. And stay tuned for future events in our Practical AI series on our LinkedIn page. If you missed the first event about a month ago about improving road safety with AI-enabled sensors, you can read a blog with the highlights and also lessons, or watch the footage, which can be found on the Academy's website. And thank you all for joining us, and I hope to see you again at the next event, which I believe is taking place on the 29th of January. Thanks again all, and thanks again to our panelists.